to the cloud. All right, so today we're going to investigate another ratio that we can use when we want to investigate the relative frequency that things happen. So last time we talked about a relationship called probability. And bottom line, whether it was dealing with empirical probability, which is when we looked at an experiment, or whether it was theoretical probability, where we looked at what quote unquote should happen, the bottom line is probability is successes divided by total. Okay, so it's the number of things that agree with my event, the number of successes divided by the total number of times the experiment happened, or the total number of outcomes. So there's a slightly different relationship that is used sometimes, and it's called odds. Okay, so what we're going to start with is odds against an event. And so the way you calculate the odds, it's a slightly different relationship. The odds against an event is calculated like this. So notice it's the odds against something happening. The ratio is this: the probability that the event fails to happen divided by the probability that the event successfully happens. Now, we're going to mainly deal with equally likely outcomes, and you're going to see this pattern, but I just thought I would type it out for you, that you'll see that we can stop at some point dealing with probability and just go failures divided by successes. That's what the odds against is. It's a different ratio. It's the ratio of the failures to successes. So for instance, my first example right here, example 1, says determine the odds against, okay, rolling a 4 on a die. Okay, so the odds against look like this. It's the probability that I fail to, I'm going to abbreviate, it's the probability that I fail to roll a 4 over the probability that I successfully roll a 4. Now, I don't know about your brain. My brain has a hard time going with the probability of failure. I don't know why. So I always start with the success and go from there. If you don't have any such problem, you're younger, you have a fresher brain than me. So I'm sure you're probably much more able to comprehend. So the probability that I successfully roll a 4, well, let's review. What is the probability that I successfully roll a 4? There's 1 4 on the die out of 6 sides. Fantastic. What's the probability that I fail to roll a 4? It is perfect, 5 out of 6. Okay, fantastic. So I've got 2 fractions here. So just a quick little review, and once you do this once, you'll have no problem doing it the other times. I don't know if you remember your fraction division, but the way you divide fractions is you multiply by the reciprocal. So that means to flip that bottom fraction. So instead of 1 over 6, it becomes 6 over 1. I can reduce these 6's. I got a 6 in the numerator, a 6 in the denominator, so I can get rid of them. And so what that ends up equaling is the ratio of 5 failures for every 1 success. Now, normally odds are written, because we're not used to writing a 1 in the denominator of a fraction, so we don't tend to do that. So in odds you would, but more commonly odds are written like this: 5 with a colon and 1. Or you can say 5, the odds are 5 to 1. I will use the colon. So I'm going to repeat this a few times because I want to make sure that you internalize this one thing about odds and how it's different than probability. It's a different ratio. Okay, so this is telling me when I say that odds against rolling a 4 are 5 to 1, I'm saying that for every 5 failures, I will get 1 success. And just like probability, odds only make sense in the long term. You with me so far? All right, well then do exercise 1. Very similar. You're rolling a die and you're determining the odds against a number less than 3. All right, so my odds against are going to be the probability that I fail to roll a number less than 3 over the probability that I successfully roll a number less than 3. So again, I'm going to start with the success. What's the probability that I successfully roll a number less than 3? Perfect. There's 2 numbers less than 3 out of the 6 sides of the die. That's great. And so then what's the probability I fail to roll a number less than 3? The other 4 sides, 4 out of 6. By the way, as a little aside, when you're doing your odds, a nice quick check is that both of these things should add up to 1. Because odds, failure and success, those are the only 2 outcomes you could possibly have. So when you add up the number of failures plus the number of successes, that should be the total number of outcomes. So like in the first problem, 5 failures, 1 success, that was 6 total outcomes. We saw that in our denominator. 4 failures, 2 successes, that adds up to 6, which is my total number of outcomes. So that helps you do like a quick check that you're not off base. So again, at some point you'll probably stop doing this, but I'm just going to make sure to keep doing all this work. The 6 are going to cancel. I can also reduce by a factor of 2. So let me rewrite this because I know fractions are scary. 2 goes into 4, 2 goes into 2, 2 goes into 4 2 times. 2 goes into 2 1 time, and so then I end up with the odds are 2 to 1. Once again, what does that ratio mean? I have 2 whats? Failures for every 1 success. Great. Okay, that's what the odds are telling me. It's a 2 to 1 ratio of failure to success. All right, if you have a question, be sure to ask it. If I'm going too fast, if I'm not explaining things well, please let me know. Other than that, do exercise 2. Okay, I've got some billiard balls there. Okay, so my odds against, again, probability of failure divided by my probability of success. So I'm determining the odds against it being having the green color. Okay, well, what's the probability I successfully grab a billiard ball here with green on it? Yep, there's 2 of them that are green out of 15. Fantastic. If you said 1 out of 15 because you assumed solid green, okay, I'd give you that. I wasn't super specific, but I was just meaning green at all. If you ever play pool, solid stripes, that's how the balls are labeled there. Okay, so then I'm going to go with 2 out of 15, and then the other 13 out of 15 do not have any green on them. Are we so far so good? Again, at some point, if you following the pattern, you say, oh, I can just cancel these denominators. Fantastic. I love it. That's learning, but I'm just going to keep writing because I don't want to lose anybody because I know fractions are scary. I'm going to cancel those 15s, and I'm left with the ratio of 13 failures for every 2 successes. Still doing good? All right, then exercise 3. Basically, you know everything you need to know from this section. Now we're just going to do more examples. Exercise 3, now the odds against a number less than 5. All right, so odds against are the probability of failure divided by the probability of success. So once again, what's the probability that I succeed in getting a billiard ball with a number less than 4, or excuse me, less than 5? Yep, there's 4 of them. 1 through 4 are all balls in that picture. And then I have 11 out of 15 is the remainder. And so then I have 11 out of 15 divided by 4, or 50, excuse me, divided by 4 out of 15, which I make the reciprocal. The 15s cancel, and I'm left with 11 failures to every 4 successes. That's my ratio. All right, just another situation you're going to see when you go through your homework. I've got this spinner right here. So go ahead and calculate the odds against the spinner landing on green. While I'm thinking of it, I'm just trying to send an email to the tech support about this so that hopefully after spring break, we don't have that problem anymore. Anyway, so the odds against the probability of failure divided by the probability of success. So the probability that I succeed in getting green is what? Perfect. Great. It seems like you all are doing well with the probabilities. So I'm glad you followed my advice and did that homework thoroughly. And if you haven't, just please make sure that you do. And so we end up with 5 failures to 3 successes. Okay, so we're going to flip the page. There's another related ratio, and this is actually not going to be anything new or difficult. In fact, you already have all the information you need to answer this. So sometimes you want the odds in favor. Okay, so all the odds in favor are is you're flipping the ratio. So when it's in favor, since favorable is good, what we do now is we put the successes on the top. Okay, so once you've calculated the odds against, you automatically have the odds in favor. So for instance, on the last problem that we just did, we calculated the odds against landing on green is 5 to 3. So then knowing the little bit you know now, if I said, what are the odds in favor of green, then you would guess what? 3 to 5. Perfect. There you go. Once you've got one, you've got the other. So I know some of the homework problems are going to ask you for both. There's no real extra calculating involved. They're just trying to make sure that you understand the relationship between successes and failures in both of these. So on the next page, exercise 5, I've asked a problem that combines questions about probability with odds because I want to make sure that you're discerning the difference. So we see Anne has 12 bills in her wallet. So good to be her, flush with cash. She's got 6 1s, 2 5s, 3 10s, and 1 20, and she's going to select one at random. So if you would, please answer the 4 questions related to Anne's wallet. Okay, so the first one, the probability that she selects a $5 bill. Okay, so what's that relationship? What's the ratio you wrote down? Perfect. There's two $5 bills, so that's successes, divided by, now if you made this mistake, don't beat yourself up. That's why I'm asking the question, is because I expect some of you to get lulled to sleep. So I totally understand. Okay, but the denominator is now the total. So the denominator here is 12, not 10. Okay, so this is two successes out of 12 total outcomes. And so that reduces to 1/6. I'm going to leave it. I'm not going to use a decimal since we're going to calculate our odds in a minute. What's the probability it's not a 5? How many not 5s do I have? 10 out of 12. Great. So I'm going to reduce that. 2 goes into the top and the bottom. 2 goes into 10 5 times. 2 goes into 12 6 times. There we go. So now you have the information you need to calculate the odds against. The odds against is the probability I fail to get a $5 bill divided by the probability I successfully get one. So that is 5 out of 6 divided by 1 out of 6. And when I cancel those 6's in the denominators, or if I go through the whole thing of multiplying by the reciprocal, either way, I end up with the odds are 5-1. So Anne, when she goes into her wallet, if she's just picking bills at random, she's going to fail every 5 times that she experiences one success. That is how that works. And then the last one is just now introducing the odds in favor, which is the same ratio, but just flipped. And so what are we going to write down for D? 1 to 5. Perfect. Love it. Yeah.
On the test, do we have to reduce it all the time?
You always reduce fractions. Odds are always written as a reduced fraction no matter what. Yeah.
Even the big numbers, because on the video last Monday they didn't reduce the big
On the
numbers.
probabilities, when it came to those big numbers, I just went right to decimals, but you don't write odds as a decimal. So you always reduce. I'm not going to give you any tragic numbers on the test, don't worry. But any numbers you would reduce as fully as you can. Yes.
Do we convert these probabilities to decimals?
I'm not going to, because you can, if on your page you wrote I think it's 0.1667, and that is fine. To calculate the odds, it's easier to do with the fractions because it's just a quick multiply by the reciprocal. If you have the ratio of decimals, then you've got to multiply to get rid of the decimals, then you got to reduce those numbers, and then you've introduced rounding because these are non-terminating decimals. So it's quicker and cleaner to just keep the fractions in this case. But in general, probability, you can write either as a reduced fraction or a 3 or a 4 digit decimal rounded appropriately. And no problems there. All right, so go ahead and do exercise 6. One card is selected from a deck. What's the odds in favor? So make sure you're reading that. We're doing the odds in favor this time of selecting the queen. All right, so odds in favor, I've just flipped the ratio. It's the probability of success divided by the probability of failure. So what's the probability that I successfully draw a queen from the deck of cards?
4.
There are 4 out of 52. We only had this one card problem, so I didn't reprint the card. So hopefully if you needed it, you had it in your notes or you Googled it real quick. On the test, I will give you the image of the cards. You don't have to memorize that. So 4 out of 52, there's 4 queens. And then there are 48 other cards out of the 52. So again, I'm going to multiply by the reciprocal. So the 52s cancel. I also noticed that 4 goes into both of those. 4 goes into 4 one time. 4 goes into 48 12 times. So the odds in favor are 1 to 12. So since this is the last odds problem where we're calculating them, I'm just going to ask this. In this case, the 1 represents what? Successes. And then the 12 represents failures, okay, because it's odds in favor. Wonderful. All right, just a couple more problems and we're done with this, this section right here. Now what we're going to do with these last 3 problems is we are going to do the reverse. Let's say we're in an instance, we are given the odds, and then I want to calculate what's the probability that's related to that. Okay, so in this, my example right here, I've got the odds against Robin being admitted to a particular college are 15 to 4. So it's a competitive thing, and these are the long-term odds that have been published. Determine the probability that Robin is admitted to the college. Okay, great. So we want to know what's the probability that Robin is admitted. So I gave you here in this problem, I gave you the odds against. Please just be sure that you're reading carefully. Odds against, since that's the odds against, my 15 to 4, what's the 15 represent? 15 represents failure. Because odds against are ratio failure to success. The 4 represents success. 15 failures for 4 successes. That's the ratio. So if we want to know what's the probability Robin gets admitted, what's the number that represents how many times she will successfully get in?
4.
The 4. Okay, now here's the key. This is the difference between probability and odds. What am I going to put in the denominator of this? 19. Yes, said with authority. I love it. 19, because remember, failures plus successes, that's all the possible outcomes that you can have. So she has a 4 out of 19 chance of being admitted to whatever college she is dreaming of going to. Everybody with me? All right, then go ahead and do exercise 7 and prove it. It's all you do. Well, you reduce the fraction, you could make it a decimal, but since that's already a reduced fraction, I'm stopping there. Okay, so the odds in favor of Mark selling his motorcycle through an online service is 3 to 10. Determine the probability that Mark sells his motorcycle. Great. So again, just want to make sure you're reading carefully. This is the odds in favor. So when something is the odds in favor, this time the 3 is going to represent what? Success. And the 10 this time represents the failures because we are doing odds in favor. All right, so what's the numerator of Mark's probability going to be? 3 successes out of, what's the total? Perfect. You can make that a decimal if you want. It's already a reduced fraction, so I'm done with the problem. All right, one more. Go ahead and do exercise 8 right down there. I did a little Google search when I made the worksheet and came up with those odds. If you like the NBA, then you're aware that Golden State's playing pretty good. All right, so this time, again, it's odds against. So odds against means my 9 to 2 is the ratio of failures to successes. So if I'm trying to figure out the probability that they win the championship, what's my numerator going to be? 9 to 2, it's odds against, so the 9 represents failures, the 2 represents successes. So the numerator of my probability is going to be the 2, because that's the number of successes out of what's the total going to be? 11. So just to address this, if my question was, what's the probability they don't win? So what's the probability they fail to win? Well, now the numerator of that is going to be 9 out of the 11 total times. Okay, so odds against are failures to successes. Yes, question in the back.
So if it's odds against, does the success always go to the numerator?
So this is odds against their winning. That's what the success and failure is related to, whatever it's the odds against happening. So I don't know why you would want this, but if somebody had created the odds against losing, okay, then in that case, a success would be losing, right? So does that make sense? So whatever it's the odds against, this is the success right here. So like if you look along, odds against being admitted. So success was being admitted. Up here was odds against the $5 bill. So the success was the $5 bill. So that's a really great question to be able to discern. Whatever comes after the words odds against, that is what success is. Or same thing with odds in favor. When we did the odds in favor here of odds in favor of the queen, okay, whatever comes after that, that's success. Okay, great question, love it. Any others?